Welcome to lesson number 5, Attributes of Blockchain. Let us see what we are going to cover in this particular lesson. So the objective of this lesson is that by the end of this lesson, you will be able to state the 4 core attributes of blockchain technology. This lesson covers the attributes of blockchain as stated by the objective. The only expectation is that we should remember what we had covered as a definition of blockchain, as well as a little bit about the transaction flow also. If you remember that, that is great, but it is very important that you remember the definition, that you had understood the definition of blockchain technology. So let's begin. So what are the attributes of blockchain? What are the 4 core attributes that we have? The first attribute is the network topology, how the network architecture is for blockchain. The second attribute are the network participants. What are the different participants who are there in this network? What are they called? What are the different types of participants which are there? That's something that we're going to see in this particular section of the lesson. Then the record keeping process, that is the third attribute. How the records are maintained in a blockchain network. How does that happen? We're going to see that. The fourth core attribute is the agreement mechanism. What is this agreement mechanism? Why do you need that? That's something that we're going to see in the fourth section. That is the fourth core attribute. And these attributes were somewhat covered in the definition of blockchain at a very high level. And right now we are going to understand them step by step in a little more detail. So let's start with the first attribute, that is the network topology. As you can see in the diagram, there are three structures. There are three topologies which are presented. The first structure is on a is a logical representation of a centralized network architecture. The second that you can see is a decentralized logical representation of a decentralized network architecture. The third one is a network topology, that is the logical network topology of a distributed network architecture. The point here is these are the three basic types of network architecture or topologies and the intent here is to see which particular network topology does blockchain use. Does blockchain use a centralized network topology? Does blockchain use a decentralized network topology? Or blockchain uses a distributed network topology? Now these are the three topologies which are there, and we have to map which is that topology which is used by blockchain. Now we have to remember certain things that are the requirement for blockchain. Now let's just assume we are Satoshi Nakamoto. And as Satoshi Nakamoto, we are going to implement the Bitcoin blockchain network. So we just decided, okay, to implement the Bitcoin blockchain network, there are certain requirements that we have. One of the requirement is that there should never be a single point of failure in the entire ecosystem. The second requirement is that participants are able to directly communicate with each other without going through a defined path, without going through or putting any dependency on one entity for communication. It can take any path for communication. That's one thing. That's actually linked to the single point of failure. Then apart from all this, basically the copy must be there with all participants. Again, reflecting to this that there should never be a single point of failure. So this is something that our requirement is, and let's see whether these requirements can be met by which of the architecture that we can see here. Is it centralized, is it decentralized, or is it distributed? When it comes to the centralized network topology, as you can see in the diagram, that you have a yellow circle in between. Now that yellow circle is a central server, and the blue circles around it are the clients. In the previous lesson, I had stated that the traditional systems that we have right now are based on client-server architecture, and this is the topology that they follow. The yellow circle is the server which provides the services for any kind of processing which needs to be taken care in that ecosystem, and clients consume those services. Okay, so the point here is it doesn't match with our requirements. That is, you have a central point of failure here. Because if that central server goes down, all the clients go down. The entire network goes down. The central server gets compromised, all the clients are affected. The record is only with the central server. So if the central server goes down, none of the clients are able to access the records. Single point of failure written everywhere. So obviously, we won't be choosing central network topology for a Bitcoin blockchain network. Okay, now let's go to the second option that we have, that is a decentralized network topology. Now here it might create a little bit of confusion because a lot of times we refer to blockchain as a decentralized network. A lot of times we refer to blockchain as a distributed network. But the point is, which network does it really use? So let's come back to the situation which we were in right now, like selecting which network topology is the most appropriate network topology when it comes to blockchain. Okay. So here you can see in the decentralized network topology, you have a yellow circle that is again the main server, and you see some orange circles here around the yellow circle. Now these orange circles are nothing but sub-servers. They are actually decentralizing the responsibility from the centralized server. It's like sort of load sharing. You have sub-servers throughout the network. These sub-servers are connected to the centralized network, a centralized server, that is a yellow circle. And these to these sub-servers, that is the orange circle, you can see a lot of blue circles are connected. There is like clusters of them which are connected, correct? So what happens is that even if one or two orange circles go down, only those clients who are attached to that particular sub-server won't be able to access the network, won't be able to get all the services, but the network is still up and running for others. But so what's happening here is that single point of failure is getting prevented to some extent, but not completely. A part of the network is still down, right? And those clients are not able to access because the sub server which they were connected to went down. So this is a problem with decentralized network topology. So, but and again, if the entire central server goes down, the entire network goes down. So the point here is we cannot prevent single point of failure if we adopt decentralized network topology. So what is a network topology which is best suited for blockchain is the peer-to-peer network topology that we see in the diagram. In this, you can see that there is no yellow circle, there is no orange circle. All you can see is all blue circles which are connected with each other. What it means is there is no servers here, there are no clients, there are just peers connected with each other, meaning there is no dependency on a central entity. All the peers act like client as well as servers. So depending on the situation, they will provide services and consume services. The data is shared across all the peers. They are connected with each other. There is no defined path for any two peers to communicate. There is no dependency as such. They can take any path they please like to communicate with another peer in the network. And even if one or two peer goes down, there are so many other peers in the network who are there to provide you with the services and the records in the network. So this is something very suitable for us. So yes, blockchain uses a distributed network topology. Now the point here is there is a confusion. Like we stated blockchain is decentralized and right now I'm stating it is distributed. Just to sort that confusion out, if you have to see logically when we talk about blockchain in general, it is decentralized with one meaning to it. What it means is that there is no central entity governing the network, and that is the reason why we state that logically it is a decentralized network. Okay. But if you have to see on the technical front, it is not using a decentralized network topology. It is using a distributed network topology. It is using a peer-to-peer network topology, and that is the reason logically it is technically it is a distributed computing network. So blockchain uses a peer-to-peer network architecture. Peers consume as well as provide services. They're inherently resilient because if you have multiple participants in the network, even if one or two participants go down, there are other participants who are up and active to provide you with the services. More peers, better the network because it will become more resilient, because even if a lot of peers go down, there are more peers who are available in the network which can provide you with the services and the records which are necessary. Example, if anyone has used the torrent network, the BitTorrent for downloading movies. I know it's illegal, but just stating it, that's something which is using a peer-to-peer network architecture. Meaning when you're downloading some kind of file, it's not actually getting downloaded from a centralized server, rather someone else's computer in the torrent network. That's something very close that we have come across when it comes to peer-to-peer network. Okay. So this is the first attribute of blockchain technology, that is the network topology. Blockchain technology, that is the network topology, and it uses a peer-to-peer distributed computing network topology. Let's look at the network participants. Now, what are participants? Now, all the participants who are upholding the blockchain network are referred as nodes. They are called as nodes, meaning they are connected with the network and they support the various operations and functioning, and they are called as nodes. In general, they are called as nodes. Peers in blockchain terms, mostly they are referred to as nodes. Now, depending upon the type of functionalities, there are different types of nodes in the network. If you have to take an academic institute has a lot of players, a lot of entities within that academic institute, correct? There are students, there are teachers, there are deans, there is a principal, and there is teaching, there is non-teaching staff. So many entities are there within the academic institute. How do you classify them? You classify them as per the roles and responsibilities that they have. Students have to attend lectures, give examinations, teachers have to teach, take lectures, take assessments, principal has to manage the entire college. So, how do you define an entity? You define an entity by the roles and responsibilities that they are playing. Exactly in this case, also, even if it is an ecosystem, basically, Bitcoin blockchain is an ecosystem. It has a lot of participants in the network, it has a lot of nodes in the network. Now, those nodes are connected with each other, but all the nodes also have some kind of roles and responsibilities as well. So, there are three basic types of nodes in the Bitcoin blockchain network. The first is the full node. What are full nodes and what are their roles and responsibilities? Full nodes are those nodes which maintain the entire copy of the ledger, meaning all the transaction details which have happened till date, starting from 2009 till up till now. How many ever transaction, whatever transaction details are all maintained by full nodes. So they maintain the entire copy of the ledger. Then it comes to light nodes. What does light nodes do? Now the point here is if people just want to do Bitcoin transaction, it's going to be very complex that they have to install the Bitcoin client, Bitcoin software, set up the node, take care of the entire technicalities, and then do Bitcoin transactions. That's going to be tedious, right? So avoid that. And for anyone to do Bitcoin transaction, there is services which have come into existence. That is the wallet services. What do you mean by wallet services? Let's just take an example of internet service provider. When it comes to internet service providers like ISP, if you want to access the internet, you don't have to become an internet service provider. You just have to merely take services from an ISP. Exactly the same thing. If you just want to do Bitcoin transactions, you're not into all the technicalities of Bitcoin node and blockchain and all those things. You just want to do wallet Bitcoin transactions. You just have to use wallet services. So basically, when you're utilizing wallet services, you're utilizing the services given provided by wallet service providers, just like in the case of internet service providers. Now, these wallet service providers obviously need to be a part of the blockchain network, Bitcoin blockchain network. They have to be a part of the network. They have to be a node in the network. Those nodes are called as light nodes. So light nodes are those nodes which are providing the end users for doing Bitcoin transactions. So there is a difference between participants and users. Participants are nodes in the network. Users are merely consuming the services of that ecosystem. Okay. Then the third type of node is the mining node. Mining node is the most critical participant in a public permissionless blockchain like Bitcoin. As I stated in the transaction flow, the special nodes who are responsible for forming the block, they are called as mining nodes. So mining nodes, we have also heard them as also know them as miners. You might have heard. So miners are the third category of nodes. They do maintain the entire copy of the ledger. So a lot of functionality is same like the full nodes. But what is the difference is that they are involved in the competition. That is the game theory. They are involved in the solving the challenge. So they are involved. They have a lot of hardware capability because the challenge is hardware intensive, it is computationally intensive, and that's something that we'll be seeing on later. So I hope we are clear with the network topology, that is peer-to-peer. Participants, that depending upon the functionalities, there are different kinds of participants, full nodes, light nodes, and mining nodes when it comes to Bitcoin blockchain. So let's look at the record keeping process. That is the third core attribute of blockchain. How does the record keeping process happen in blockchain? The record keeping process, now obviously businesses, as I stated in the introduction also, businesses don't act independently. They are connected with each other, and any kind of transactions which are happening within the business needs to be recorded. So you bring in all the entities are connected with each other, all the entities are maintaining the copy of the ledger. So If it is in a look, ledger can exist in two ways. Either it is in a siloed way or either it is in a centralized way. If you have to take the bank's case, it is centralized. If you have to take entities which are connected in a business ecosystem, but their IT infrastructure is not connected, that means it is in a siloed approach. It is in an individual approach. But when it comes to blockchain, it is in a distributed fashion, meaning the copy of the ledger is with all the participants who are there in the network. Okay. So as you can see, the traditional approach and the blockchain approach. In the traditional approach, you can see the bank is responsible for maintaining the copy of the ledger. So the entire responsibility of the security and integrity of the ledger is with the bank. But when it comes to the blockchain network, you see that all the participants are maintaining the copy of the ledger so that there is no dependency on any kind of on one participant. Rather, it is with everyone. The copy of the ledger is with everyone. Now that brings us to the question, then how does that happen that the copy remains the same? That is the fourth core attribute of blockchain technology, that the network topology has to be distributed with the help of a peer-to-peer computing network. There has to be participants, and roles and responsibilities of the participants need to be defined. The ledger keeping, the record keeping process will happen in a distributed fashion, and that's why it's called as a distributed ledger. The copy of that distributed ledger needs to be same throughout the network, and for that consensus mechanism is required. Consensus word means agreement by a group of people. Here it is a group of computers. All the group of computers need to come to a same decision that this is the copy of the ledger, and that is why consensus mechanism is required. So let us just revise on the properties of blockchain once again. Blockchain uses a peer-to-peer network architecture. Blockchain is a distributed ledger of all transactions. Blockchain has no central authority. So the point here is, how can everyone trust what is a single universal truth? How do you trust that this is the truth? So to do so, there is some kind of consensus mechanisms which need to be placed. That is why it is called as an agreement mechanism. If you remember that in the transaction flow, after the validation process, these valid transactions are collected by the miners. Those are the special participants, and then they form the block. Whoever is able to form the block by solving the puzzle first gets to put the block ID into the network, and that particular block will get propagated throughout the network if it is a valid block. Correct? Because every participant would validating that particular block for all the transaction details and everything. So once you're doing the validation, you're adding it to your own ledger as well. So what will happen in some time if it is a valid block? Everyone will start adding that block after validation to their own ledger before propagating it to the adjoining participants. So on and so forth, the entire network receives that block, and in some time everyone will have the same copy of the block, meaning everyone will have the same copy of the ledger. So that's how the entire network is pushed towards consensus. And this kind of consensus mechanism, especially in Bitcoin, that is the consensus mechanism which got introduced with the help of Bitcoin, is called as a proof of work consensus mechanism. There can be different kinds of consensus mechanisms. Okay. So what is the takeaway of this particular program of this particular lesson is that the network topology is peer-to-peer. Irrespective of any kind of blockchain network, it is always going to be peer-to-peer. Let it be public, let it be private, whatever kind of blockchain network it is there, it's always going to be peer-to-peer. There will be participants, there will be nodes, and they will play different kinds of roles. We just took the example of Bitcoin for full node, light node, and mining node. But when it comes to any kind of other platforms like Ethereum, the types of participants may change, but there is always types of participants in the network. Record keeping process will always happen in a distributed fashion when it comes to blockchain, irrespective of what blockchain network type of blockchain network it is. The agreement mechanism, there has to be some kind of consensus mechanism which is implemented into the technical layer itself, irrespective of any kind of blockchain platform it is. And in particular to Bitcoin, we saw that the consensus mechanism is proof of work. So what are the four core attributes? Let's just recap quickly. Network topology, peer-to-peer, distributed computing network. Network participants are called as nodes. Depending upon the types of functionalities, there are different types of nodes. Record keeping process always happens in a distributed fashion, and that's why it's called as a distributed ledger. The fourth is the agreement mechanism, and that is the consensus mechanism, which is required for all the entities in the network, all the participants in the network to come to the same conclusion. to come to the consensus that this is the copy of the ledger throughout the network. Thank you.